So example 3, we have a project calls for 3 pieces of wood. The longest piece must be twice the length of the middle-sized piece, and the shortest piece must be 10 inches shorter than the middle-sized piece. If a board 70 inches long is to be used, how long must each piece be? So let's go ahead and read that one more time for step 1, reading it twice. A project calls for the 3 pieces of wood. The longest piece must be twice the length of the middle-sized piece. The shortest piece must be 10 inches shorter than the middle-sized piece. If a board 70 inches long is to be used, how long must each piece be? So to point out, we're comparing this long piece and the short piece, we're comparing it with the middle-sized piece. And we don't have any information about our middle-sized piece other than it is some length. So since we have 3 quantities, and our step 2 is assigning these quantities, we're going to say that X is our middle-sized piece. This is our middle-sized piece. Because we're using this X as the comparison. So now for our long piece and our short piece, we can just manipulate X. So we know that our longest piece is twice the length of the middle-sized piece. So 2 times X is going to be our longest piece. Then our shortest piece is 10 inches shorter, 10 smaller. So we can represent this as X minus 10 because it was 10 inches shorter than the middle-sized piece. So this here is our shortest piece. So now we've assigned values to each one of our unknowns, or we've assigned variables, expressions. So now we can move on to step 3, where step 3 is our equation. And we know that the total length we're using, or the total length is 70 inches. So we need to see how long each piece has to be to equal 70 inches. So this means that we can take the longest piece plus our middle-sized piece, middle-sized piece, plus our shortest piece, and this is going to be equal to our total, or the total length. And now we can use our assigned expressions. So our longest piece we said was 2x. And we're adding this to our middle-sized piece, which we said was x, which we're then adding to our shortest piece, which was x minus 10. And this is equal to our total length, which we said was 70 inches. So writing out this equation, this is going to give us 2x plus x minus 10 is equal to 70. Now we can use step 4. Step 4, we now just want to solve. We see here that in our equation, our x minus 10 is in its simplest form, and changing or taking out a parentheses doesn't change our equation, so we're going to go ahead and just take out those parentheses. So we're going to say this is 2x plus x minus 10 is equal to 70. And we want to combine our like terms. So 2x plus x is going to be 4x minus 10 is equal to 70. And now we want to use our addition property of equality to get rid of our minus 10 so we can isolate 4x on the left side. This will give us 4x minus 10 plus 10 is equal to 70 plus 10. So now we've canceled out our minus 10 on the left-hand side to get 4x is equal to 70 plus 10, which is 80. So now we have our constant on one side, our x variable on the other, and now we just need to simplify. So we're going to divide each side by 4. 4 divided by 4 is just 1, so we're going to get x is equal to 80 divided by 4. 80 can be separated into 4 times 20, and then we have 4 divided by 4, which is just 1. So we're going to get that x is equal to 20. So we found our value of x, and we need to find our value of 2x and x minus 10. So now for step 5, we're going to definitely run out of room again. So 1 second here, we'll make some more room. So writing out step 5, we know that x is equal to 20, which is, this is in inches, and this is our length of our middle sized piece. Then 2x is 2 times 20, which is equal to 40 inches. And this is the length of the longest piece. Then lastly, we have our shortest piece, which was x minus 10, which we simplified to 2 minus 10, which is just 10 inches. And this is the length of the shortest piece. So we've solved these values. We know what each one of our pieces, the length of each of our pieces are, but we just want to check step 6. So we want to plug in all of these values in our original equation, which was 2x plus x plus x plus 10. So we want to plug in 20 for x, 40 for 2x, and 10 for x minus 10. And our original equation was 2x plus x plus x plus minus 10 is equal to 70. So now we're replacing these values. 2x we said was 40 plus x, which was 20, plus x minus 10, which was 10, is equal to 70. 40 plus 20 is going to be 60. Then we have 60 plus 10, which is indeed equal to 70. So when we have 70 equals to 70, we checked our answer, we found it was correct. So this means that our final answer, our solution from step 5, was our final answer. So we had our middle-sized piece was 20 inches, our longest piece was 40 inches, and our shortest piece was 10 inches. So let's move on to objective 4. Objective 4, we're going to solve problems involving consecutive integers. This is kind of a new idea that we have. 2 integers that differ by 1 are called consecutive integers. So in general, if x represents any integer, then x plus 1 represents the next greater consecutive integer. So if x is equal to 4, x plus 1 is equal to 5. So 4 and 5 would be consecutive integers. What we see here is that consecutive even integers, such as 2 and 4 or 8 and 10, those are going to differ by 2. And so do consecutive odd integers. Consecutive odd integers, such as 1 and 3 or 9 and 11, also differ by 2. There's just even and odd instead. So if we had the number 4 for an even odd integer, the next greater even integer would be 6. And if we had odd integers, say 5, our next greatest odd integer would be 7. So we have kind of our graph here with our consecutive even integers. So we want to move 2 units. with even integers. We also want to move 2 units for odd integers. It's just that the actual value of them is different by the sense of even or odd. So in general, if x represents an even or odd integer, then x plus 2 represents the next greater consecutive even or odd integer respectively. So another problem-solving hint. We have that if x is equal to the lesser or the least integer in a consecutive integer problem, then the following apply. We say that for 2 consecutive integers, we use x and x plus 1. For 2 consecutive even integers, we use x and x plus 2. And same goes for consecutive odd integers. We use x and x plus 2. So kind of using these hints, we're going to go ahead and do an example. So example 4, if the lesser of 2 consecutive odd integers is doubled, the result is 9 more than the greater of the 2 integers. And then we want to find the 2 integers. So using that step 1, let's read that one more time. If the lesser of 2 consecutive odd integers is doubled, the result is 9 more than the greater of the 2 integers. And we want to find our 2 integers. So using our problem-solving hint, we said that we're assigning x as the lesser or the least integer in a consecutive integer problem. So in our example here, the lesser of 2 consecutive odd integers is doubled. So we're going to assign, so step 2, we're going to assign x as the lesser consecutive odd integer. And we're going to write this quite a few times. So we're going to say that this is the LCOI, the lesser consecutive odd integer. Odd integer. So this means that if x is the lesser consecutive odd integer, x plus 2 is going to be our greater consecutive odd integer. And we're going to call this the GCOI. So I'm going to write this a few times, and it's just going to take up too much time to write it. So we've assigned our values. We said x is the lesser consecutive odd integer, and x plus 2 is the greater consecutive odd integer. So let's move on to step 3. Step 3 tells us that if the lesser consecutive odd integer is doubled, so we're going to say double the lesser consecutive odd integer. So we're saying that if this is doubled, the result is 9 more than the greater of the 2 integers. So in this case, we're going to say that double the lesser consecutive odd integer, quite the mouthful. We're going to say that double this is going to be equal to 9 more than the greater of the 2 integers. So 9 plus our greater consecutive odd integer. So this is how we're formatting it. And since we have double, this is telling us that's going to be 2 times x is equal to 9 plus x plus 2, because that was our greater consecutive odd integer. So this equation is 2x is equal to 9 plus x plus 2. So here's our equation. And now for step 4, we want to solve. Our x plus 2 is in its simplest form. We're just adding, so our parentheses don't matter, so we don't have to write them. So we're going to write 2x is equal to 9 plus x plus 2. And we want to combine like terms. This will give us 2x is equal to 11 plus x. And we want to isolate x to one side. And we see that our 1x is less than 2x, so we're going to subtract 1x from each side. And this will give us 2x minus x is equal to 11 plus x minus x. And when we simplify this, 2x minus x is going to give us x, and 11 plus x minus x is just going to be 11. So we found our value for x. We're saying x is 11. So then in step 5, since we have that x is 11, this is our lesser consecutive odd integer. So if x is 11 and x plus 2 is going to be 11 plus 2, which is 13, and this is our greater consecutive odd integer. So we found our values. We're saying our lesser consecutive odd integer is 11 and our greater consecutive odd integer is 13. But of course, we need to check. So step 6, we're going to plug in 11 for x and 13 for x plus 2. And our equation was 2 times x, so 2 times 11 is equal to 9 plus x plus 2, which is 13. So 2 times 11 is going to be 22, and 9 plus 13 is also 22. So our solution for our lesser consecutive odd integer being 11 and our greater consecutive odd integer being 13 is correct. So step 5 here is our final answer. And that concludes section 2.5. So I'll see you again for our next section, everyone.